Welcome to the video session of 1 year calculus in 5. This marks the end of the week, and I would like to personally congratulate everyone that has participated in the competition thus far, which is sadly 1% from its commencement. This video provides the assistance needed in solving this week's question, and it will be released at the end of the week. At the end will be the results of the week. This week's problem asks us to find the limit of a function, which is a quotient of two polynomials. We would have to restructure the fraction to a function that's continuous at s equals to 0. Let's begin.
2, 1. It's clear that the numerator approaches 0 as x approaches 0. And this is because the numerator, this barrel is not working well, but we have to keep going. This is because the numerator of x at x equal to 0. Please don't mind the notation I'm using. My handwriting is not good, both on computer and in real life, so let's manage this. The numerator of x when x equals to 0 is equal to 0 to the power of 4 minus 3, 0 to the power of 3 plus 8 times 0 to the power of 2. Since we have 0 in everything, this will equal to 0, this will equal to 0, and this would also equal to 0. So at the end of the day, everything equals to 0. So the numerator would equal 0. But that doesn't necessarily mean that the function, that doesn't mean that the whole function x power of 4 minus 3 x power of cube blah 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 would tend towards 0 when x equals to 0. And this is simply because the denominator, that is, as the numerator tends to 0, the denominator also tends to go to 0. That is, if you plug in 0 into the denominator, you get 0 to the power of 3 minus 2 times 0 to the power of 2. So you just get 0 also. And you know in mathematics, whenever you have 0 divided by 0, you have a very big problem. So you cannot divide by 0. So since the numerator and denominator both tend towards 0, you can't use that method of substitution.
If it were a normal case, we would have to just If it were a normal case, we would just have to substitute the approaching value of x into the limit. But because of the null or zero denominator, we would have to restrict the denominator in a way that it does not approach 0 as x, which is 0. One way to do that, which I'm not sure if that is the only way,
that is by factoring out x squared from both sides of the numerator and denominator. So let's factor out x squared from both sides. We have x squared. From the first term, x power of 4, if we divide both sides by x squared, we'll have x squared again. The second term is minus 3x cubed. If we divide both sides by x squared, we'll have minus 3x. And the third term plus 8x squared. If we divide both sides by x squared, we'll have plus 8. Divided by, from the denominator, by the time we factor out x squared, we'll have x squared. If we divide x cubed by x squared, we'll have x. Minus, if we divide 2x squared by x squared, we have 2x. No, we have 2. So now x squared will cancel out x squared, leaving you with 2x squared minus 3x plus 8 divided by x minus 2.
and now that the limit can be evaluated nicely, plug in x equal to 0, or rather evaluate
x. You can evaluate the function at s equal to 0, just like you would have done in the previous case. Okay, we have 0 minus 3 times 0 plus 8 divided by 0 minus 2. 0 and 0 is meaningless. 0 here too is meaningless. So all in all, you have 8 divided by minus 2, which is equal to minus 4. So the limit of all this is simply just minus 4.
Therefore, the limit of as x approaches 0 is minus 4. That simply means that the closer s gets to 0, the function gets to -4. I will leave it as a test for yourself. Evaluate the function at s equals to 1, -1, 0.5, -0.5, 0.1, and -0.1. And you'll notice that the number gets closer and closer to -4. Well, that brings us to the end of this solution. Big thanks to Professor Chris McMullen for the question. If you would like to submit a future 1 year calculus question, please do so at akubigobdk@gmail.com. Let's take a look at the cumulative report. Nobody participated. Next week question is coming soon. Don't forget to invite your friends, your family to the year of fun. And I can't wait to see your solution. Good luck and thank you for watching.